Hi, I'm Joel Siegel, and I'm the Lab Director for Liberty Oilfield Services. And I'm going to talk a little bit about our flow loops that we have available in various regions that we work. What is a flow loop and how do we use them? Most importantly, how can our customers utilize them to save money? First, I'll give you a brief description of the apparatus itself. Then I'll tell you how we generally use the flow loops. Next, I'll provide examples of a good run and a bad run so that you can interpolate the reports for yourself. I'll then tell you about our typical QC process and then draw some conclusions. To the right is a picture of our flow loop in one of our field labs. It takes up quite a bit of space, mainly because it has to have 10 feet of straight tubing in which to take pressure readings. It's a very straightforward piece of equipment. At its most basic, it's got a bucket with a paddle mixer to mix the fluid. It takes about 20 liters for a single test, and it's got a progressive cavity pump to pump the fluid around the loop. The loop consists of two sizes of tubing, 1/2 inch and 3/4. The fluid will first travel through 10 feet of 1/2 inch tubing on the way out, and then comes back to the mixing bucket through 10 feet of 3/4 inch tubing. Pressure transducers measure the pressure drop along both sections of tubing. The data collection and instrument control is automated, which makes for efficient testing, cleanup, and turnaround time. So what are the ways we use these flow loops? We use them in several different ways. One of the primary roles is to aid in selection of products for our product line. We like to select the best products on the market so that we can be a large volume customer, which allows us to have the best pricing. That being said, we are more than happy to provide our customers with FR options. Our flow loops are available to any customer that wants to compare and contrast various FRs in their own source waters. We regularly evaluate the performance of the newest FRs on the market, and we'll be happy to share this information should you have questions or concerns. We also like to compare FRs from the same or from different vendors in order to ensure that we're getting the same performance today as what we got yesterday or last week or last year from the same product. We like to optimize or match the friction reducer to your specific source water. Do you require a higher cost mid-brine, or will a freshwater FR suffice? Obviously, this helps to minimize costs. If you need to change source waters in the middle of a job, the FR loop can provide confidence that the FR on site will still perform optimally. We also check for compatibilities with the flow loop. Some products that we add, such as biocides, can have a negative effect on FR performance. The loop enables us to check for those issues and to understand what the maximum level of a given additive should be. Also, some products, such as FR boosters, can aid the performance of FRs in stress waters, and the loop helps us to optimize these products. Finally, if you plan to utilize produced water on your frac job, the loop can help determine if the product at hand is capable or if it might require some dilution with fresher water. Understanding what you can and can't get away with can help save money. I want to quickly go over what the data looks like from the flow loops. What does good FR look like? To the right is an example of what we would call pretty good flow loop data. On the chart, we're showing data for the friction loss in purple, the temperature in red, and the flow rate and shear rate in brown. So why do I think the data on this chart looks pretty good? As you can see, the sample is injected at just after 1 minute. From there, the sample inverts rapidly to a maximum friction loss that is both high and stable from between 1 to 6 minutes. At 6 minutes, we increase the shear to maximum flow to see if the friction loss remains stable. The stability here indicates that the fluid will not lose efficiency at high shear rates. This particular flow loop maxes out at just over 65% friction loss. Other loops will max out at similar but slightly different levels. After the initial 6 minutes, we run a multi-shear step between 300 and about 4,800 reciprocal seconds to get a feel for performance across all shear rates that might be encountered in the field. Loss in performance at any of these steps can cost money through the need to run additional friction reducer on the job. Now that you've seen an example of good data, it should be easy to spot bad data. The chart to the right is the same test profile run as in the previous example. So why do you think the data on this chart looks pretty bad? As you can see, the sample is injected at just after 1 minute. From there, the sample inverts a bit slower than the previous good run to a maximum friction loss that is both lower and less stable between 1 to 6 minutes. At 6 minutes, we increase the shear to maximum flow, and the sample continues to shear down, indicating that the sample is not shear stable and won't tolerate increases in job rates. As you can see, the flow loop makes spotting poor performers simple. So now I'll talk about how we QC our FRs typically and draw some conclusions. As early as possible prior to the start of the job, LOS will request multiple 5-gallon water samples to the lab. How much we actually need generally depends on what is being planned, so talk with your sales guy. Synthetic water can also be used, but is generally not preferred. These samples are used to select the best price to performance friction reducers for your job, accounting for anticipated produced water blend ratios and any anticipated possible contaminants. A properly designed friction reducer system ensures optimum performance, particularly when using recycled produced water. The flow loop allows us to easily screen for the highest performing product. Any loss in FR performance can lead to tens of thousands in cost overruns. Thanks for watching this introductory video on our flow loops and how to use them. For more information, please visit libertyfrac.com.